Hello and welcome to MyScience Tutorials. In today's video, we are going to be talking about Raoult's law and freezing point depression calculations. Before we begin, if you are new to MyScience Tutorials, kindly consider subscribing and pressing the notification button so that you don't miss any of our latest tutorials on biology, chemistry, mathematics, and physics. So let's begin. Now, in our first two previous tutorials, we did mention what colligative properties are and their examples. We also did look at the vapor pressure depression and then the boiling point elevation and the relationship between them. Now in today's tutorial, we want to look at the relationship between the freezing point depression and lowering of vapor pressure. Now whenever we add a solute to a solution, the vapor pressure of the resulting solution decreases, and hence it increases what the boiling point of the solution. Now with the increase of boiling point, it also decreases what the freezing point. Hence we have what we call as the freezing point depression as one of the colligative properties. Now the change in freezing point can be represented by what delta T, which is equal to what T final minus T initial, to get our change in the freezing point of the resulting solution. Now delta T, can be given mathematically as delta T is equal to what Kf multiplied by W multiplied by 1000 all on small m multiplied by capital W, where we are saying this is what the change in freezing point, or the freezing point depression, change in freezing point, and Kf is the what? Is the freezing point constant. This is the freezing point constant. Freezing point constant. The small w is the mass of solute. Mass of solute. The small m is the molar mass or the molecular mass of solute. And capital W is what? The mass of the solvent. Alright, now we have 1000 over here because ideally, we dissolve the mass of the solute in 1 kilogram of the solvent. Now there are instances where we may dissolve the solute in 0.1 kilogram or 100 grams of the solvent. Now when that happens, it means our freezing point depression becomes what? Kf multiplied by W multiplied by 100 all on small m times W, capital W, where all the other parameters have the same definition, but the only difference is here is 1000 and here is 100. So for the 1000, it means we dissolve the solute in what? 1 kilogram of the solvent. But then where we have the 100, it means we dissolve the solute in 0.1 or 100 grams of the solvent. Alright, now there are some times where Kf, or the freezing point depression constant, can be given to you. There are other instances where it may not be given. So in case the Kf is not given, how do you calculate the Kf from the parameters that will be given to you in the question, so that you can be able to go ahead and calculate for the molar mass or any other thing that the question may require of you. So the Kf can be calculated from the formula RTF squared over 1000 multiplied by LF, where Kf we know is the freezing point constant, Tf is the freezing point of the solvent. So we have freezing point of solvent. That is for the Tf. We have Lf. The Lf over here is the molar latent heat of fusion. So molar latent heat of fusion, and then the R is what? Is the gas constant. Alright, so with this formula we can calculate the value of Kf, and once we get Kf we can easily substitute Kf into this equation and we can calculate for any other parameter that the question may require of us. So now with this basic introduction, let's go ahead and solve some few examples to actually get well acquainted with problems on freezing point depression. So the first example we want to look at is 0.440 gram of a substance dissolved in 22.2 grams of benzene lowered the freezing point of benzene by 0.567 degrees Celsius. We have to calculate the molar mass of the substance, given that Kf is equal to 5.12 degrees Celsius per mole. Alright, so let's write down our solution. First of all, I would like to code the formula. We have Tf delta T is equal to what? Kf multiplied by W multiplied by 1000, all on small m multiplied by capital W. Now we have 0.440 gram of the substance, so it means the mass, which is the small w, of the solute is what? 0.440 grams, was dissolved in 22.2 gram of benzene, so it means the capital W over here is equal to what? 22.2 grams. So it lowered the freezing point of benzene by this, so it means our delta T is what? 0.567 degrees Celsius. And then we have to calculate for the molar mass, given that Kf is equal to 5.12 degrees Celsius per mole. So straight ahead, we can go ahead and find our molar mass. So if I make m the subject from here, it means our molar mass will be equal to what? Kf multiplied by W multiplied by 1000, all divided by delta T multiplied by capital W. So it means our molar mass is equal to the value of Kf is what? 5.12 multiplied by small w, which is 0.440 multiplied by 1000, all on delta T is 0.567 multiplied by capital W is 22.2. So if we input everything here into the calculator, we are going to get 178.97. So it means the molar mass of the substance, given that Kf is equal to 5.12 is equal to 179 gram per mole approximately. So this is the molar mass of the substance. Now let's look at another example. Example number 2. So we have 1.250 gram of naphthalene was dissolved in 60 cm³ of benzene, and the freezing point of the solution was found to be 277.515 Kelvin, while that of benzene is 278.495 Kelvin. Density of benzene is 0.880 gram per cm³. Kf is equal to 5.1 Kelvin per 1000 gram of benzene. So we have to calculate the molar mass of benzene. So let's write down our solution and look at the parameters that we have. So from the question, we know that the small w, which is the mass of the naphthalene, is what? 1.250 grams, and it was dissolved in 60 gram of benzene. So we know volume of what? Solvent is what? 60 cm³, and the freezing point was found to be this, and that of benzene is this. So if we look at this, we can say that of benzene is higher, so it means our delta T straight away from here will be what? 278.495 minus what? 277.515. Okay, so that will give us the value of our delta T. Now, okay, let's see what else we have. The density of benzene, so density of what? Solvent is what? 0.880 gram per cm³, and we were given Kf, so we have to calculate for the mass of naphthalene. Now if we look at this, we know delta T, as we already know, is what? Kf multiplied by W multiplied by 1000, divided by what? Small m multiplied by what? Capital W. Now we can see that we have everything in the question except capital W. So it means we need to find what? The mass of the solvent first before we can proceed to find any other thing. So we know that mass concentration, okay, or the density over here is what? Mass over volume. Okay, so now that we have this, so we are saying our mass will be capital W. Okay, so if we make capital W the subject, it means we have to multiply our density by the volume. So our mass of the solvent is density, which is what? 0.880 multiplied by the volume, which is what? 60 cm cube. So we multiply that by 60, we are going to get 52.8 grams. Alright, so now that we have the value of our capital W, we can substitute that back into the formula and find the molar mass of the naphthalene. So if we make M the subject, we know we are going to get Kf multiplied by W multiplied by 1000 all over what? Delta T multiplied by what? Capital W. Alright, so delta T here, if we do the subtraction, we are going to get 0.98 Kelvin. So our molar mass is what? Kf, which is what? 5.1 given to us over here, multiplied by 1.250, that is the small w over here, then multiplied by 1000 divided by the change in temperature, or the freezing point is what? 0.98. Then we multiply it by the value of the capital W, or the mass of the solvent that we found, that is what? 52.8. So if we input everything here into the calculator, we are going to get 123.20. So it means approximately the molar mass of naphthalene is 123 grams per mole. That is approximately. Alright, let's have a look at one final example, then we end this beautiful tutorial. So we have a solution of 0.124 gram of substance X in 25 liters of ethanoic acid, has the freezing point of what? 0.324 degrees Celsius, below that of pure acid. Sorry, this is supposed to be pure, not this. So this is what? Pure acid. Okay, acid, which is 16.6 degrees Celsius. So we have to calculate the molar mass of S, given that specific latent heat of fusion of ethanoic acid is 180.75 joules per gram, given that R is equal to what? 8.314. All right, so let's write down our solution. So we have a solution of so it means the mass, small w, is what? 0.124 grams of substance S. Now the volume of the ethanoic acid, or our solvent, is what? 25 liters. Okay, so has a freezing point of this below that of pure acid. So it means the delta T is equal to 0.324 degrees Celsius. Alright, so we have to calculate the molecular mass of this, given that latent heat of fusion, that is LF, is equal to 180.75 joules per gram, and then R is equal to 8.314. Alright, so we know that our delta T is equal to what? Kf multiplied by small w multiplied by 1000, all on what? Capital W by what? Small m. Alright, so from here we can see that we don't have Kf, so we need to find what? The value of Kf. Right, so if we calculate the value of Kf, we are going to use the formula RTF squared over what? 1000 LF. So it means our Kf is equal to what? 8.314. This is the temperature of our pure ether, that is Tf, is equal to what? 16.6. So we use that. It's in degrees Celsius, so we convert it to Kelvin, so we add 273, and that will give us what? 289. This is 89.6 Kelvin. So this multiplied by what? 289.6 all squared divided by 1000 multiplied by the LF was given to us in the question as 180.75. So this is equal to, if we input everything here into the calculator, we are going to get what? 3.86 as the value of our Kf. So now that we have the value of Kf, we can go ahead and calculate for our molar mass of naphthalene. So it means from here, if we make M the subject, we are going to have Kf multiplied by small w multiplied by 1000 all on, then we have delta T multiplied by what? Capital W. Alright, so we have our molar mass to be equal to our Kf that we've calculated was 3.86 multiplied by W, which is 0.124 multiplied by 1000 on delta T is 0.324 multiplied by. Now we have W. We were given volume, but we were not given any density for us to be able to calculate for the weight of or the mass of the distance. So because we were not given W and capital W, and we were only given the volume to be 25, and we're not given density for us to be able to manipulate and calculate the value of our capital W, we use the 25 there as the weight or the mass of our solvent. So we multiply this by 25. Now it means our mass will now be our molar mass, will now be equal to what? 59.09 gram per mole. Okay, so it means our molecular mass of X, okay, is now what? 59.09 gram per mole. Alright, so thank you so much for watching, and I will see you in the next video. Bye bye.